In this video, we'll look at how to form the conclusion of our hypothesis test. So let's suppose that we have a two-tailed test and our test statistic has turned out to be 2.02 and our p-value is 0.0434. So at this point, I'm going to look at my significance level. And in the first scenario, we're going to say that the significance level is alpha equals 0.05. So because this is a two-tailed test, that means we're going to split the alpha between the two tails. So we're going to have alpha over 2 in the right-hand tail, and that's going to be 0.025. And so that's going to look a bit like this. And then we have the same area in the left-hand tail as well. And that forms our critical regions. So now I want to know what are the critical values, the z values that correspond to those areas. And so I can use the inverse norm function in order to find those critical values. And in this case, we have 1.96 and negative 1.96. So now I can compare those critical values with my test statistic. Since the test statistic is 2.02, that's going to fall right about here. And we can see that that is within the critical region. So that tells me to reject the null hypothesis. Now that's using the critical value method, which you don't necessarily want to do. Maybe you want to use the p-value method. So I could take my p-value, which is 0.0434, and just compare that to alpha. Since alpha is greater than p, that also tells me to reject the null hypothesis. So that's what we're doing in the case where alpha is 0.05. What if alpha instead was 0.01? Then we have a smaller critical region because we have a smaller area in the tail. So now we're going to have alpha is 0.01. That makes alpha over 2 turn out to be 0.005. So very small area in the right-hand tail. Again, small area in the left-hand tail. And our critical values are going to be 2.576 and negative 2.576. And now when I compare my test statistic of 2.02, that is not in the critical region. And if I compare my p-value to my significance level, I can see the p-value is larger. So the p-value is the area past the test statistic going into the tail. We can see that that's covering there. We're going to make a matching negative 2.02 on the other side because it's a two-tail test, and cover that, and we see that the p-value is larger. So because the p-value is larger, or because our test statistic is not in the critical region, we fail to reject the null hypothesis, or do not reject the null hypothesis. So that's how we conclude whether or not to reject the null hypothesis. Next, you need to write a statement regarding the initial claim. So let's take a look at a problem where we have a claim that the mean distance run is different from 10 kilometers. So in the beginning of the problem, you would write your null and alternative hypotheses. So your null hypothesis would be that the mean, or mu, is equal to 10, and the alternative is that mu is not equal to 10. So, since the claim is that the mean is different from 10 kilometers, that makes the alternative hypothesis the claim. And when the alternative hypothesis is the claim, we're always going to use the word support in our final statement. So, either we're rejecting the null hypothesis or we're failing to reject the null hypothesis. If we decided to reject the null hypothesis, so we have the null, we have the alternative, we don't like the null, we rejected it. So that means we like the alternative, which was the claim. So we would say there is sufficient evidence to support the claim. And then we just state whatever the claim was, which was that the mean distance run is different from 10 kilometers. If we fail to reject the null hypothesis, then we don't have sufficient evidence against that null hypothesis. Didn't mean to wipe that out completely. So we don't have evidence to support our claim, and so we would say there is not sufficient evidence to support the claim because we're not rejecting that null hypothesis. Now, this is when the alternative is the claim. What if the null hypothesis is the claim? So now we have the null hypothesis, again, is mu equals 10, because our statement is that the mean distance run is 10 kilometers. The alternative is mu is not equal to 10. But our claim now is the null hypothesis because the claim said the mean is equal to 10. So if we reject the null hypothesis, then we're going to say there is sufficient evidence to reject the claim. So when the claim is the null, we're going to use the word reject. Our decision was to reject the null hypothesis. There is sufficient evidence to reject the claim because the claim is the null. And if we fail to reject the null hypothesis, so we like the null hypothesis, don't like the alternative, then there is not sufficient evidence to reject the claim. Again, we have to use the word reject. So we'll just say there's not sufficient evidence to reject the claim that the mean distance run is 10 kilometers. And that's how you form your conclusion of your hypothesis test.